Hello. In the last video, we went over what I call the fencing task. And what we did there is we took a set amount of fence length that you have to make a rectangle, and we maximized the area you can make with that given perimeter. That is one example of how you can use a quadratic and optimization to figure out a maximum value. Today I'm going to take you through some more optimization problems dealing with quadratics. So sometimes we will get a maximum value and other times we will get a minimum value. Let's take a look at some examples. So the first question here says, what is the maximum value of the function y equals negative x squared plus 2x plus 5? Now this is a maximum value, and that should make sense if you're familiar with transformations of functions. The negative here flips our parent function of x squared over. And when it does that, flipping it over the x-axis that is, it makes it look like this right here. And then x squared, remember our usual parent function there, looks like this. So if it's asking for a maximum value, more than likely that a value right there is going to be negative. And if it's asking for a minimum value, the a value is going to be positive. A nice easy way to remember that is if that leading coefficient there is negative for quadratics, you get like a sad face here, right? And if that leading quadratic is positive, you're going to get a happy face. And if it's a happy face, we have a minimum value at the vertex. And if it's a sad face, you're going to have a maximum value there. Not that this has anything really, you don't need to know that for this problem. It's telling you there's a maximum value there, but it's a nice little trick to know, and it comes handy sometimes. All right. Now we want to know what the maximum value is, so we want to know where that vertex is on that equation. And in the last lesson we said we can figure out that vertex by using negative b over 2a. So if I have the function negative x squared plus 2x plus 5, to figure out the x coordinate of that vertex, I'm going to say, well, this is negative 1 is my a value. Positive 2 is the b value. I really don't need to know c here, but c is positive 5. Put it into the equation, and negative b becomes negative 2, and 2a is just 2 times negative 1. This all simplifies to negative 1. That is the x-coordinate of my vertex. So I've got some beautiful graph that looks like that. And the x-coordinate here is going to be at negative 1. I still want to know where is the y value there. So to figure out the y value, I'm going to substitute it back into the equation there. Technically, if we're speaking, it's a little bit abstract to put it like this, but this max value occurs at negative b over 2a, comma, the f of negative b over 2a. All I'm doing is saying plug this x value into the function and get the y value out of it. So we found the x value, it's negative 1. I now need to put it into this equation right here. I'm going to write it over. So we got negative 1 squared. I'm sorry, this isn't negative 1, is it? I went too fast with that. That's a positive 1. So this should be positive 1 squared. And then plus 2 times 1 plus 5. So 1 squared is 1. I get negative 1 plus 2 plus 5 here. And this gives me 6 as my value right there. So the maximum value occurs at 1 comma 6. All right, next question is question number 2. Try that one out, pause the video, and then we'll come back and check your work. All right, I've taken it that you've given it a try. Let's now see if you got the answer right. So looking at this, I've taken the function, written it out, and I've identified the a, b, and c. The question is asking for the minimum value, and that makes sense. Our a value there is positive, which means that the parabola is going to look like this right here, and it's going to have a minimum value down there. So I want to know where is the x-coordinate of this. It's going to be at negative b over 2a. I've identified my a, b, and c there. So b is 2. That puts me at negative 2 there up top. And a is 1/3. So I'm going to have 2 times 1/3 right here. This equals negative 2 over 2/3. And to simplify this, I'm going to keep that top one the same. I'm going to switch to multiplication and flip this fraction. And so I got negative 2 over 1 times 3 halves. The negative 2's cancel. And I end up with just negative 3 here as my x-coordinate. So the x-coordinate is negative 3. Let's write that down. To figure out the y-coordinate, I'm going to put it in for x right there and solve. So let's do that. We get 1/3 times negative 3 squared plus 2 times negative 3 plus 5. That's the same thing as 9. And that is negative 6 and plus 5. 1/3 of 9 is 3. And so 3 plus a negative 6 is negative 3. And then plus 5 gives me 2. So my answer right there is at negative 3 comma 2. That is the minimum value there on that function. All right, let's look at the next one. Now the next one gives us a word problem here. And everybody loves word problems because this is where we apply math, right? So it says the height in feet of a rocket after X amount of seconds is given by that function right there. What is the maximum height reached by the rocket and how long does it take to reach that height? So there's two questions here. What's the max height? And the second question is, how long does it take to reach that height? I want you to give it a try, pause the video, and then we'll work it out together. All right, let's take a look and see if you got that question right or wrong. If we're looking at this, you might say, wait a minute, this is asking me to find the max height, and it's positive right there. Doesn't that go against what you said at the smiley and frowny faces? Well, no, it doesn't, because this is not in standard form. Our highest exponent here is not out up front. Let's move that negative 16x squared to the front. That will also make sure we get the correct A and B value there. So now that is negative, so if you're drawing your face like that, look at that, you're going to have, negative people don't smile, do they? Nope. We're going to have negative, negative, and it's going to look like this. So we will have a max on this. So that does match up. And another thing to note in word problems like these are to be careful of your variables. What is X representing and what is Y representing? When we just do questions like this, there is no representation there. They're just X's and Y's. But this, X is representing time. See how it says X amount of seconds? And the height is going to be our Y value. So this is a Y value and time is an X. So if you're graphing this out, the Y-axis would be height and then the X-axis would be in seconds there. And you'd get some graph like that where H is your max height and right here is the amount of time it takes. So that's what we're looking at when we're answering those two questions right here. The maximum height is going to be our Y value, and how long it takes us to reach that height, that how long part right here is going to be X. This is going to be our Y value on the vertex of that parabola. So let's go ahead and solve that. We've got negative b over 2a, so negative 128 over 2 times negative 16, which is going to give me negative 32. And now I've got negative 128 divided by negative 32. Let's punch that into our friendly calculator here. So 128 divided by 32 gives me 4. I guess I could have done that in my head, but when I do it in my head on video recording, it always messes up. So there we go. Positive 4 is what we get. That is our X value. And now to find the Y value, I'm going to put it into the function. So I'm going to end up with negative 16 times 4 squared plus 128 times 4 here to get a maximum height. So 128 times 4, 128 times 4 gives me 512. This becomes 512. 4 squared is 16, so you end up with negative 16 times 16, which should be negative 256. And I believe that's exactly half of that, but let's just go ahead and add 512 to it, and it is 256 is our answer. That should be positive, and that makes sense because we're talking about height. We're not going to have a negative height, at least not on this one. There are cases in physics when we're doing problems we get a negative height, but don't worry about that for right now. So this is 256. Keep in mind that our units here, this is, if you're just talking about math and graphing, 4 comma 256 is where the max height occurs. That point right there is the vertex of the parabola. But if you're talking about the actual word problem in the context, it takes 4 seconds to reach 256 feet. That's the height right there. So that answers both questions. If you want to put it in a complete sentence, that's great. No, that's the lawnmower question. What is the max height? You can say 256 feet. And how long does it take? It takes 4 seconds. Remember, our original problem told us the units are seconds there for time. Okay? Let's try out number 4 here. Let's get on to that lawnmower question. It says the equation for the cost of manufacturing lawnmowers is blah, 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 blah. What is the number of lawnmowers should be produced to minimize costs? That's not blah, 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 blah. Let me read it out in case you're just can only hear the audio. It's 0.008x squared minus 0.04x plus 75. That's your function. So pause the video again and give that one a try. All right, welcome back. I know that problem's a little bit confusing because there's a lot of decimals in there, and usually I encourage students to work only with fractions, but decimals we can still work with also, and that's what we're going to do here. We're going to do decimals all the way through. So we've got 0.008, that is our A value. The negative 0.04, that is our B value. This is our C value, although it's not really necessary unless we're actually finding the zeros of the function and we're using the whole quadratic formula. We're going to use negative B over 2A to find the vertex. So our B value is negative 0.04. When I put that in, it's going to become positive 0.04. And 2 times this is going to give me 0.016. And so if it's helpful, you can do it like this. You can say 0.04 divided by 0.016, and you get 2.5. Now, take a look here at the graph just so we can kind of get a visual. I know when we put these decimals in here, it's kind of hard to visualize the graph sometimes. This is the graph, and I've zoomed it out quite a bit. Notice we got negative 500 to 500. That's the scale we're on. So our minimum value is somewhere down in there, and it should be at x equals 2.5. If we zoom in, it becomes kind of hard to see it with this scale. I guess I could change the scale, but I think this is far enough right here. If we drag along somewhere in here, there is a 2.5. Oh, they got it right there for us. Desmos tracks it. 2.5 is our minimum value, and then this right here is the actual minimum cost if we were to put it into the function. So it costs $74.95 per lawnmower. If we make 2.5 lawnmowers, that is minimizing our cost. Now, realistically, that sounds ridiculous because you can't make, well, you could make 2.5 lawnmowers, but what good does it make, what good does it do a company for us to just make 2.5 lawnmowers, right? You want whole numbers of lawnmowers. But sometimes that's how the math works out. And then a company can decide, do I want to make 2 lawnmowers or 3 lawnmowers? Obviously, that's not going to make any money if they're only making 2 or 3 anyway, but that's how we can apply it to certain situations. Now, if we look at number 4 here, no, sorry, that was number 4. Let's look at number 5 now. Number 5 looks like this. It says, what are the dimensions of a rectangle of greatest area that can be formed with 200 feet of fence? Now, we talked about a similar one on this when we did the fencing task in that one video, so you could use that to help you out. But what we really need to do here is come up with the equation ourselves. And I think this is pretty cool because so many times when you're doing optimization problems like this, look at these previous examples, I gave you the equation. And you're thinking like, okay, that's great. But when in real life are they going to throw an equation out to me? And generally you don't have that equation. You got to come up with it yourself. So that's what we need to do in this case. We know that perimeter is 200 feet. I want you to come up with the quadratic equation. So a couple of hints on that. I want you to draw a rectangle. And once you get that rectangle, I want you to come up with a few equations and see if you can come up with a quadratic and then maximize the area. So pause the video and I'll give you hints along the way. All right, so I don't want to give you all the answers at once to this problem, but you can pause the video at each step and see, how long it takes you to get it yourself. So I've got a rectangle, and I'm going to call one side x. And I know that rectangles, the opposite sides are congruent, right? So this side right here must also be x. I know that my perimeter, all four sides added up, are going to give me 200, right? So this x plus this x plus these two sides equal 200. So I need to come up with two more sides right in here. And so when I add up all four sides, I get 200. Now, a few things about this. I know if I add these two x's up, I get 2x, right? So that plus that equals 200. And I can subtract 2x from both sides. So this plus this equals 200 minus 2x. Now, whatever this side is right here, it has to be the same as this one. So I'm calling these, you can call it whatever you want. We can call it a triangle if we want. It doesn't have to be a letter. So I've got two triangles here. And that equals 200 minus 2x. Divide both sides by 2, and I get a triangle is equal to 100 minus x. Or you can say that instead of calling it a triangle or y or whatever variable you want to call it, this is what this side must be. 100 minus x here and 100 minus x there. So notice if I add up all four sides, let's do that again here. If I add up all four sides, I've got x plus 100 minus x plus another 100 minus x, right? There are two sides that are 100 minus x. There's two sides that are x. If I add all those up, what do I get? Well, x plus x gives me 2x. I can add up the 100s. I get 200. I can add up the negative x's. I get negative 2x. And then 2x and negative 2x cancel out. You're left with just 200, which is what all four sides add up to. So we're just building here to get this shape right there. So if you make this side 5, this side is 95. And you say 5 times 95 gives me an area. If you make this side right here 20, this side becomes 100 minus 20, which is 80. And 20 times 80 gives you the area. So that comes up with, that's how we got our sides there in terms of x. Pause the video again and see if you can get an equation that goes for the area for us. All right, did you get your equation? Let's take a look at where we just left off and see if you got it right. So here's our rectangle. So the area of a rectangle is length times width. So I'm just going to say x times 100 minus x. That is your function there, right? So x times that, distribute your x, and you end up with 100x minus x squared. And I can move this, put it in standard form, and I get negative x squared plus 100x equals your function for that. So you give me this side length right here, and I can tell you what the area is. Notice the f of x right here is standing for area because we made it equal length times width. And now we have a quadratic equation. Isn't that cool? You came up with that equation. It wasn't just given to you for the word problem. But now we want to know, how can we maximize the area? What x value will maximize it? So now we can use our little trick where we say negative b over 2a, that is going to be our x-coordinate of the vertex. And remember, I know that this is going to give me a graph that looks like this with a maximum because that leading coefficient there is negative. So he's going to look like a sad face, right? So negative b over 2a, 100 is my b, and negative 1 right there is the a value. So I get negative 100 over 2 times negative 1, which gives me a positive 50. That means I need that side length to be 50. So that's one side length. Let's write that in. 50. That's what your x value is. So if x is 50, what must be this length right here? Well, 100 minus 50, which is 50. that will give us our maximum area there. And you could figure out the area just by saying 50 times 50, and that would give it to you. Or you could put it into this equation right here, and that would also give you that max area. And so, was it 2,500, right? 50 times 50. Just because I'm having a slow day and make sure I'm doing it right in my head. Yep, 2,500. Sometimes, we have a hard time just adding, depending on the day, right? So that gives us our max area, and we'll learn, if you haven't seen it already, between watching the fencing task video and doing this one right here, that if you're given a perimeter, if you make that square shape, it's going to give you your maximum area just by making a square. But still, it's a fun activity, I think, to go through there. All right? So there are 5 problems that go through maximizing or minimizing a quadratic, and I can give you more if you want more problems, or if you have any questions, let me know. Thanks for watching.